Alright, so in this video we're going to be talking about properties of definite integrals. And we'll be looking at four properties. The first two are a lot like the indefinite integral properties that we saw in an earlier video. So the definite integral of f plus or minus g, so a sum or difference of f and g, is equal to the definite integral of f plus or minus the definite integral of g. And the limits are going to be the same. So the integral of a sum is a sum of the integrals. Alright, the second property is the integral of a constant times f. And that's going to be a constant times the integral of f. So constants can move outside of integrals. Third property, now this is one that's unique to definite integrals. If you take the limits of an integral and you swap them, so instead of going from a to b, you go from b to a, that's going to be negative the limits the normal direction from a to b. So swapping the limits introduces a negative sign. And then the last property, if we have an integral from a to b, and we add it to an integral from b to c, that can be combined into a single integral from a to c. So say we have a, b, and c here, and some function f of x. Then what this last property is saying is that this area, the integral from a to b, plus this area, the integral from b to c, is the area from a to c. Alright, so let's do some examples where we use these properties. So the first example, let's say we have the integral from 1 to 2 of g of x, and we know that it's 4. And we have the integral from 2 to 1 of f of x, and we know it's 3. And we are asked to find the integral from 1 to 2 of 3 times g of x plus f of x. Alright, so we'll start by splitting this integral using the first property. So the integral of a sum is the sum of the integrals. So we can split it like this. Then we can use the second property to bring that 3 outside the first integral. And what's left here, the integral from 1 to 2 of g of x is going to be 4. We want to use the integral from 2 to 1 of f of x is 3, so we're going to swap the limits on this second integral, changing its sign to negative. Alright, now I can use my givens. So the integral from 1 to 2 of g of x is 4, so this will be 3 times 4. And the integral from 2 to 1 of f of x is 3, so we'll have 12 minus 3, which is 9, as our answer. Let's do another example. So in this example, we're given the integral from 0 to 2 of f of x is 3, and the integral from 0 to 3 of f of x is 4. And we're asked to find the integral from 2 to 3 of f of x plus 4. Okay, so again, the first thing we're going to do is we're going to split this using the first rule. And this second integral doesn't have f in it, so this is just a normal integral. We can evaluate this. We'll come back to that. Alright, so to evaluate this first integral, we've got to use the fourth property. We write it over here. The fourth property says if we integrate from 0 to 2, and we add the integral from 2 to 3, that's going to be the same as the integral from 0 to 3. We know the integral from 0 to 3, that's 4, so this is 4. We know the integral from 0 to 2, that's 3. So let's write it down here. This will be 1. And then we can evaluate this second integral. This is just going to be 4x by the fundamental theorem. We could put 3 and 2 into that and take the difference. So we'll get 1 plus 4 times 3 minus 4 times 2, which is 1 plus 4, which is 5. All right, I hope you found this video useful.